Welcome back. In this video, we are going to solve problem 14-16 that is taken from chapter number 14, Energy Methods, and book name is Mechanics of Material by R.C. Hibbeler. So statement is determine the bending strain energy in A992 steel beam due to the loading shown. Obtain the answer using the coordinate x1 and x4 and then x2 and x3. I is 53.4 inch power 4. So you can see this is the beam where the loading is shown from this point till this. We have 8 kips per feet. At this end we have pin support, and at this point we have a roller support. So you have to find the bending strain energy due to first x1 and x4 coordinate and then x2 and x3 coordinate. So let's start with the solution. Let this is your point B and this is your point A. So if you remove roller support at point B, so you will be having a reaction force which is equal to RB, and that will be upward because this load is downward. So it will be upward, and this force will be, if you remove this reaction support, so the reaction force at RA will be also downward. And let this is RA. So we will first find this RA and RB by using equation of equilibrium. So first equation of equilibrium is that sum of all moments about point A is equal to 0 and taking the counterclockwise moment as positive. First we will convert this 8 kips per feet uniformly distributed load into point load. So it will be act at the middle. So this load will be 8 into the length, which is 5 feet. That will be 40 kips. Clear? And this will act at a distance of 5 by 2, which is 2.5 feet. Okay, 2.5 feet. Okay, this 5 feet is also equal to 5 into 12, which is equal to 60 inch, and this will be 10 into 12, which is 120 inch. Clear? So later we will convert them into inch. Now we will apply equation of equilibrium at point A. So first equation of equilibrium is that this load into perpendicular distance is 10 feet, and this is producing counterclockwise movement, so it will be positive. So I will write RB multiply by 10. The second movement is due to this load, which is 40 kips, and perpendicular distance will be this 12.5 feet, and this is producing clockwise movement, so it will be negative. So I will write minus 8 multiplied by 5 into perpendicular distance is 12.5. Their sum must be equal to 0. So 10 RB is equal to 8 multiplied by 5 multiplied by 12.5. So from here you will get this RB will be equal to 50 kip. Now you have this RB, you can apply another equation of equilibrium, that is sum of all forces along y direction must be equal to 0 and upward force is taken as positive. So RA, which is downward, so minus RA plus RB, which is upward, and that is 50 kips, minus this distributed load when converted into point load is minus 40 is equal to 0. So from here we will get this reaction force by the support will be equal to 10 kips. Okay. Now you have this reaction force, so we will go toward our first part to find the bending strain energy for coordinate x1 and x2. So what we know that this bending strain energy is equal to integral from 0 to L m square dx over 2EI. So we will find moment for coordinate x1 and then moment for coordinate x2. So for x1, I will write for x1 coordinate, we will cut the beam over here and draw the free body diagram. So it will be like this. This is beam, this is coordinate x1. Clear? Here at this end we have RA, which is downward, and that is 10 kips. Clear? So when you cut it, you will be having a shear force that will be downward, and you will be having a moment M. That this is point 1, and this will be reaction moment at point 1. So we'll find this M1 by using equation of equilibrium. that sum of all moments about point 1 is equal to 0 and taking the counterclockwise moment as positive. Remember that this x1 is taken as inch. Clear? Okay, so about point 1, the movement will be, first movement is reaction movement, which is counterclockwise, and that is m1. So I will write plus m1. The second movement about point 1 is this 10 kips into perpendicular distance x1, and this is producing counterclockwise movement. So it will be negative. It will be also positive. Okay, that will be also positive. So I will write plus 10 into x1 is equal to 0. So it means that m1 is equal to minus 10 x1, and the unit will be kips into inch. So this is the moment for coordinate x1. Now we'll find moment for coordinate, sorry, x4, because in first portion it is x4. So for coordinate x4, x4. So x4 you can see is over here. So we will cut the beam over here and draw the free body diagram. So this is the beam. Clear? This is the coordinate x4. Clear? This is the uniformly distributed load, which is 8 kip per feet. So in inch it will be 8 divided by 12. Clear? Kips per inch. Clear? Okay, so this distributed load when converted into point load, so it will be equal to this 8 over 12 into distance, which is x4. X4 is in inch, so that will give you unit kips. That will give you kip. Clear? And that will act at a distance of x by 4 from either side. So I will write x4 over 4, x4 over 2, x4 by 2. Okay, and when you cut it, you will be having a shear force V2, V4, and you will be having movement clockwise, that is M4. This is 0.4. So we'll apply equation of equilibrium, that sum of all movement about 0.4 is equal to 0 and taking the counterclockwise movement as positive. So you can see that one moment is this, which is clockwise M4, so it will be minus M4. The second moment is due to this load, which is 8 by 12 into x4, and perpendicular distance is x by 2. And this is producing clockwise movement, so it will be negative. So I will write minus 8 by 12 x4 into x4 over 2. Their sum must be equal to 0. So I will get m4 will be equal to 1 over 3 x4, 1 over 3 x4 power 2, and that will be minus. Clear? So this is the value of bending moment due to coordinate x4. You have both the bending moments due to coordinate x1 and x4, so we will get this strain energy due to bending will be equal to integral of first m1 square dx1 over 2ei, and for the limits for x1 will be from 0 to 120 inch. Clear? So I will write 0 to 120 inch, and for m4 square dx4 over 2ei, the limit will be from x4 you can see start from here and end over here, so 0 to 60 inch. So 0 to 60 inch. Now you can just put the value ui is equal to, we can take 1 over 2e common because material is same and I is same. So you will get integral of 0 to 120 inch m1 square dx1 plus integral of 0 to 60 m4 square dx4. Okay. So put the value 1 over 2 EI into integral of 0 to 120 m1 is minus 10x1 square dx1 plus integral of 0 to 60 m4 is minus 1 over 3 x4 square whole square dx4. So ui will be equal to 1 over 2 times ei, and we will take in integral 0 to 120, it will be 100 x1 square dx1 plus integral of 0 to 60 1 over 9 x4 power 4 dx4. Clear? So it will be equal to 1 over 2 times ei into 100. Integral of x1 will be x1 cube over 3, and limit will be from 0 to 120 plus 1 over 9, and integral of x power 4 will be x power 5 divided by 5, and limit from 0 to 60. Now you will take this, the value of E, from the property table. So you can go to the property table, and from here you can see E value for A992 steel is 29 into 10 raised to power 3 KSI. So 29 into 10 raised to power 3 KSI. I is also given, which is 53.4. So 53.4 multiply by 100 over 3 x1 cube. So from 0 to 120 plus 1 over 45 into x power 4 power 5, and limit from 0 to 60. Now when you solve this, you will get strain energy due to bending will come out to be 24 kips into inch. And if you want to convert it into kip into feet, so you will divide it by 12, so that will be equal to 2 kips into feet, which is the answer of our first part. Clear? Now we will move toward second part, and in second part we have been asked to find the bending strain energy due to coordinate x2 and x3. So let's move toward another page. So in this we will solve part 2. So for part 2 we will find the bending moment for coordinate x2. So x2 is here, so you can see you will cut the beam and take the right side portion. So let me draw the free body diagram of this. So this is point B. This was your point B, and from point B till this was coordinate x2. Clear? This is x2, and total distance is this one, and the remaining this portion was given as 5 feet. 5 feet, or that is equal to 60 inch. And from this point till this point we have uniformly distributed load of how much? 8 kips per feet. Okay. And when you cut it, you will be having a shear force V2, and you will be having moment M2. That this is point 2. And what we will convert this uniformly distributed load into point load. So it will be, and the mid, so 8 into 5 will be equal to 40, and unit will be is kips. And that will act at a distance of 2.5 feet or 30 inch on either side. Okay. As we are dealing with inch, x is in inch, so we will find this m2. So how you will find? So sum of all moment about point 2 is equal to 0, and taking the counterclockwise moment as positive. So about point 2, one moment is this clockwise, which is m2, so it will be minus m2. Clear? The second moment will be due to this one load we have left is load at point B, which is RB. So RB was 50 kips. So 50 into perpendicular distance is x2, and this is producing counterclockwise movement, so it will be positive. So I will write plus 50 into x2. The third moment will be due to this load 40, and perpendicular distance will be now x2 plus 30, and this is producing clockwise movement, so it will be negative. So I will write minus 40 into 30 plus x2 will be equal to 0. So you can simplify it. M2 plus 50x2 minus 1200 minus 40x2 is equal to 0. So M2 will be equal to 10x2 minus 1200. So this is bending moment due to coordinate x2. Now we will solve for coordinate x3, and we will calculate the bending moment for the beam. So you can see this is the coordinate x3. So we will cut the beam and take the left side portion. Let me draw the free body diagram of the left side portion. So you can see this was your point A, where you have 10 kips load downward. Clear? This is your point B, where you have RB, which is acting upward, that is 50 kips. Clear? And this is the coordinate x3, where you cut it. X3 is in inch. So distance between A and B is 10 feet or 120 inch. X3 is in inch. Clear? And there is a distributed load over this portion, and this will be equal to 8 kips per feet. So if you want to convert it into a inch, so 8 over 12 kip per inch. So when I convert it into a point load, so this will be 8 over 12 into perpendicular into distance, which is x3, and that will act at a distance of x3 over 2. X3 over 2. So this is your 0.3. So now when you cut it, so you will be having a shear force V, and you will be having a moment M3. So we will find this M3 by using equation of equilibrium, that is sum of all moment about 0.3 is equal to 0, and taking the counterclockwise moment as positive. So about 0.3, the first moment is M3, which is counterclockwise, so it will be plus. So M3, the second moment will be due to this force, and perpendicular distance is x3 over 2, and this is producing counterclockwise moment, so it will be positive. So I will write 8x3 over 12 into perpendicular distance is x3 over 2. The another moment is due to this 50 kip load, and perpendicular distance is x3, and this is clockwise, so it will be negative. So I will write minus 50 into x3, and the last moment, which is produced by this 10 kips load and perpendicular distance, is 120 plus x3 inch, and this is also producing counterclockwise movement, so it will be positive. So plus 120 into plus 10 into 120 plus x3, their sum must be equal to 0. So M3 plus 1 over 3 x3 square minus 50 x3 plus 1200 plus 10 x3 is equal to 0. So from here M3 will be equal to 40 x3 minus 1 over 3 x3 square minus 1200, and the unit will be kips into inch. Okay, now we have both M2 and M3. M2 is due to coordinate x1, and M3 is due to coordinate x3. So you can just put it in this formula. Strain energy due to bending is equal to integral of 0 to L m dx m square dx over 2 EI. So for coordinate x2, it will be 0 to x2 start from here 0 to 120 inch, and I will write m2 square dx2 divided by 2 EI, and for coordinate x3. It will be x3 start from here and end here. So 60 inch. 0 to 60. And it will be m3 square dx3 over 2ei. Clear? Now we can take 1 over 2e common from both sides. So 1 over 2ei, and we will left with integral of 0 to 120 m2 square dx2 plus integral of 0 to 60 m3 square dx3. Okay, just put the value 1 over 2ei, and we will put integral 0 to 120 m2 is this equation, which is 10x2 minus 1200 dx2 square plus integral of 0 to 60 m3 is 40x3 minus 1 over 3x3 square minus 1200 into dx3. Okay. Now you can see that you have two things. One is this one, and another is this one. Either you expand them, and we will use a shorter method. So remember these equations. First we will solve this by using calculator, and this, then this. So remember this equation 40x3, this one, and we will write it on calculator. So let me write it like integral of 40x minus 1 over 3, 0.33 x square minus 1200 and its square, and limit was from 0 to 60. And when you solve this, you will get 17224,128, and if you divide it with 10 raised to power 6, so that will be 17.22 into 10 raised to power 6. So I will write 17.22 into 10 raised to power 6. Now we will solve this 2. So we will write this equation 10x2 minus 1200. So integral of 10x square minus 1200 whole square, and limit was from 0 to 120. And you click it, so you can see this is I think something is wrong. 10x square minus 1200, 10x2. Okay, it's not square. So this is not square. This is not square. So only 10x. Okay, now you solve this. So you can see 57, 600, 000 divided by 10 raised to power 6 will be 57.6 into 10 raised to power 6. So 57.6 into 10 raised to power 6 multiply by 1 over 2 ei. So 2 is there, e is 29 into 10 raised to power 3 ksi from the property table, and I is 53.4. 53.4. 53.4 will give you ui, strain energy due to bending for coordinate x2 and x3. So when you calculate it, you will get strain energy due to bending will be 24 kips into inch. And if you want to convert it into feet, so you have to divide it by 12, so it will give you 2 kips into feet. So this is the strain energy due to bending for coordinate for x2 and x3. And that was all about this problem 14-16. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it, and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. Also share my videos with your friends and help them in learning as well. Thank you for watching.